So good morning dear students. I hope you all are well. So in the last lecture we have started continuity and differentiability. Now we are going to do some questions, as I said in the previous video that we will be continuing with the first exercise. Okay, so let's start. We'll do some questions and if we get time then we'll head to the next exercise. Okay, so stay tuned. Okay, so here is the question. See, I told you in previous video that there are just 2 or 3 types. Okay, in which the first type we have seen where we are given with fx, and here you have seen that you are getting x not equal to and x equal to. Those type of questions we have done. Second type is of this inequalities one, that also we have seen yesterday in the exercise. And now this is the third type where in which we have to find the value of k. Okay, as you can see the unknown constant k, we have to find the value of this. So the question is fx is given with 3x minus 8 where x less than or equal to 5 and 2k where x is greater than 5. Find k so that f may be continuous at x is equal to. Now we are provided with one information that this function is continuous. So keeping in mind the condition for continuity, will be finding the value of k. We know that whenever a function is continuous, we can equalize its LHL, RHL and its value on that particular function. So let us do that thing. So this is an inequality case. So from here we can detect which condition will be our LHL and which will be RHL. So as function is continuous at x is equal to 5, so if we are going less than 5, then it is for the LHL case, and if we are going for more than 5, it is for the RHL. So here x is less than or equal to 5, so definitely it will be LHL, and x is greater than 5, then it is RHL. So for LHL, okay, take this. We know for LHL x tends to 5 minus of fx, okay, and we know that limit h tends to 0 h tends to 0 5 minus h. Put the value here in the function wherever h, put 5 minus h. So 3 bracket 5 minus h minus 8. On putting h tends to 0, we'll get what we will get 15 minus 8. 15 minus 8 we will get 7. So 7 is the answer for LHL. Now for RHL, what we have, limit x tends to 5 plus of fx, okay, limit h tends to 0 f of 5 plus h, limit h tends to 0. Now we don't have any value of k, we only have x, we only have 2k. So as there is no x, so we cannot put anything in place of x as 5 plus h. Okay, so our answer will be 2k only because no h is also there in it. So 2k. Now can we equalize this 7 with this 2k? So because they are the function is continuous, so we can say LHL is equal to RHL. You can write this step, and lastly 2k is equal to 7 or k is equal to 7 over 2. This is the answer. So in such a way we have to do. So what is the algorithm here? With the function, if you are asked to find the value of k so that the function is continuous at whatever value, then go on finding its LHL, RHL, then you have to equalize it and get the value of k. Isn't that easy? Okay, let's do some more questions of the same kind. Alright, now let's see this question. We are given with fx, x square minus x minus 6 upon x square minus 2x minus 3, where x is not equal to 3, k when x is equal to 3. Given f is continuous at x is equal to 3, we have to find the value of k in it, and provided we are given with the function is continuous at x is equal to 3. Now in the previous question we have seen the same question where we were asked to find the value of k, but that was of inequality case. Now this is which one? Type 1. In the very starting of this lecture, in the very starting of this topic, we have taken such type of questions only. Okay, now we are intermixing. See, two types mainly, that is this one not equal one and one inequality one, and that k is also a type, but that can be intermixed with these two forms and we can solve it. So for this question again we are given with it is continuous, so can we say that f of 3, okay, because at x is equal to 3 our f of x, that is f of 3 at x is equal to 3, we are getting k. So at x is equal to 3, the function is giving the value k, so we can put f3 is equal to k, because we know the condition for continuity that its value on the function, its LHL and its RHL, all three should be equal. So value on the function means x is equal to 3. On putting x is equal to 3, here we are given that x is equal to 3, you consider k as a result. So f3 is equal to k. Keep it as it is, okay, because we need to find the value of k. Now what? This is not equal to 3. It is not equal to 3 means maybe it is less than or maybe it is more than. Okay, so you consider any of the case, either LHL or RHL. From these two you take only one case, okay, because if you will find both, then that's not of use, because with one only we can equalize this value function, because it is already continuous. So why to find three things? Let's find only two. Okay, so let's find the RHL of this. So RHL will be what? Limit h tends to 3 plus of fx, that says h tends to 0. Okay, so here h tends to 0, it will be what? 3 plus h, put, so 3 plus h the whole square minus 3 plus h minus 6 upon wait, but first we have to check whether are we not getting 0 by 0 form, otherwise we need to solve this equation. Okay, so if you put x is equal to 3 here, so it will be what? 9 minus 3 minus 6 upon 9 minus 6 minus 3. Okay, we are getting 0 by 0 form here. Okay, so we cannot directly take our function. We cannot directly take the function. We need to first solve it. So x square minus x minus 6 is a quadratic equation, and in downside also you have a quadratic equation. So can we do like in such a way that x square minus this minus of x can be split as 3 plus 2, and in the down x square minus of 3x plus of x. Can we do in such a way? Okay, so I'm solving here. Please, you have to solve it before solving, just doing this RHL. Okay, see, I'm directly just writing the roots. Please understand how the quadratic equation has been factorized. Okay, x plus 1, this x minus 3 is cancelled with x minus 3, because this is because on putting 3 minus 3 and 3 minus 3, this is what the factor which is making our function a indeterminate form. That is why this is this is eliminated. Now we are left with x plus 2 upon x plus 1. Now this is our main function. Okay, now please come here. Limit h tends to 0, f3 plus h. Now put the value of x as 3 plus h. So it will be 3 plus h plus 2 upon 3 plus h plus 1. Okay, 3 plus 2 is what? 5. See, limit is going on. 5 plus h upon 4 plus h. Now apply the proper limits. In place of h we will put 0. We got 5 by 4. Now we can equalize this with the RHL. Okay, so k is equal to 5 upon 4. This is the answer. I hope you have understood. Okay, let's take this question. I'm taking again the same kind, but in this one explanation I want to give you. That is why I have taken this. We are given with the function fx, that is tan 3x upon kx, where x is not equal to 0. and when x is equal to 0, the function is giving 1 as an answer. Provided you are told function is continuous at x is equal to 0. Now the very first thing, as I said, this is of type 1 case, okay, where x is not equal to 0. Okay, so we can equalize the main function with the LHL or RHL, whatever. So limit x tends to 0 of fx. See, this is the value of the value of this particular at whatever the on the function, okay, wherever it is constant, continuous. Okay, so limit h tends to 0 fx, that is f0 only, equal to 0. This is the proper way of writing. Okay, and for RHL, limit x tends to 0 plus fx, limit h tends to 0 f of 0 plus h, okay, because 0 and plus of h. So in our function is tan 3x upon kx. So in place of x, 0 plus h, 0 plus h. 0 plus h is h only, so hh. Now what I have done, I have taken this k out. So 1 upon k, limit h tends to 0, tan 3h upon h. Now if you remember one formula or identity which I have told you in limits and derivatives in 11th class, that limit theta tends to 0, tan theta upon theta is equal to 1. And the same case goes to if theta tends to 0, sin theta upon theta is equal to 1. And its reverse are also 1, because that is tan theta limit theta tends to 0, theta upon tan theta is 1. And same with this also, limit theta tends to 0, theta upon sin theta is equal to 1. So that is what we are going to apply here, because limit h tends to 0, tan 3h upon h, we need 3 in the denominator, so we need to multiply 3 here in the denominator as well as the numerator. Now we can say that all this quantity is equal to 1, and we will be left with this 3 and 1 upon k. So 3 into 1 upon k will give you 3 upon k, because this whole quantity will be equal to 1 by the help of the identity. Now we can equalize this with this function. Okay, sorry, this is 1, no? Okay, yeah, this is 1, sorry, please correct it. Okay, because the value of function on x is equal to 0 is 1, so here 1. So 3 upon k is equal to 1, or k is equal to 3. I hope this is clear to you. Okay, now let's see the next question. Okay, now let us take this question. Is the function f defined by fx is equal to modulus of x continuous at x is equal to 0? Okay, now in this question I'll clear some of the doubts or like some of the queries regarding the modulus function. What is this meaning of this modulus function actually? Okay, so as you are studying from the lower classes, that whenever any negative value is there in the modulus function, it will give a positive value when it comes out, and if it is any positive value, it will be positive only. But see, that modulus function and this modulus function is connected with some link, but how you have to understand this modulus function as, see, you are given with modulus of x, your function is modulus of x. Now this x has a dual nature. What dual nature? That you will get a positive answer for sure if your x is greater than 0. Okay, this modulus of x will give you a positive result if your x is greater than 0. Now what is the another nature of this function? You will get minus of x if your x is less than 0. Okay, and you will get 0 as the answer when x is purely equal to 0. That is for sure, that is the otherwise case we are taking. So this two you always have to consider. See, in the relation and function also, and in this chapter also, whenever you see modulus of x, you have to consider its dual nature, which is positive x when x is greater than 0, and when x is less than 0, it will be negative of x. Okay, I think this thing is clear to you. Now, how you will prove that it is continuous? So always see, after this exercise I will be sharing some properties of the continuous function. Already there are some functions who are always continuous, so I'll be just giving you a note for that which functions are always continuous when whatever conditions they have, or whatever values are along with them, they will be always continuous. So you have to keep in mind that this modulus functions are always continuous. So it is always continuous, but we need to prove. So I hope you can prove it very easily at x is equal to 0. For sure, this is a RHL case, this is an LHL case, and this is for the function. Here you got 0, here also you will get 0, here also you will get 0, all the three values are 0, hence it is continuous. Now if you have a question like, if I make some changes over here, like x minus modulus of x, still it is continuous. Why? Because modulus functions are always continuous, and this whole is a polynomial function, so it is a continuous function. Okay, so you have a question also here. Let me show you. Yes, x minus modulus of x at x is equal to 0, the same question. So now what will happen here? Your fx is now x minus, so it will be what? For the positive case, x minus, if I take positive x, I am getting 0 as the answer, so I'll write 0 here. Okay, and for the negative case, x minus minus of x, which will give you 2x. So sorry, I'm just doing very roughly here. This you have to show in this proper solution, you have to show. Okay, so x, so it will become this, and for x is equal to 0, 0 is the case only. Okay, now with this you have to check which one is LHL. So for sure this is LHL, this is RHL, and this is at x is equal to 0. All three will become, it will come 0. Now you have to properly write in the steps and show me. Okay, so this question you do. See, you in this question, one more thing. See, you are getting 0, 0 as the answer. Both 0, 0. So, it's totally your choice that you can write in this three ways, or else you directly can we remove this thing and say when x is greater than or equal to 0, we are getting 0. So, instead of writing 3, you can write 2. So, it's your choice whether 3 you want to write or 2. It's both are correct. Okay. Okay, now the next question, you are given with fx as tan 5x upon sine 2x when x is not equal to k and x is equal to 0, k, continuous at x is equal to 0. Again we have to find the value of k in this. Okay, so limit x tends to 0, f of x, we are getting when f is 0, we are getting k as the answer. Okay, so keeping aside, let's go for RHL. Okay, limit x tends to 0 plus, because at x is equal to 0, f of x, in place of x 0 plus h, h tends to 0. Okay, f 0 plus h, then on putting the value of 0 plus h on place of x, so like this 5h upon tan 5h upon sine 2h. Now you know what you have to do by using the formula, that is limit h tends to 0. We have to multiply 5 and 5 here. Wait, here 5h, so in the denominator also 5h should come. So let's multiply with 5h and 5h here in the numerator. In the numerator, on its numerator and denominator we are multiplying by 5h, and in the denominator by into 2h upon 2h, just to mold it into the identity we are doing so. Okay, so as we can see, this h to h will be easily cancelled, and this will become 1 by the identity, and finally we are left with 5 upon 2. So its final answer is 5 upon 2. Hence we can say k is equal to 5 upon 2. So it's the answer. Okay, I hope you are getting the questions now. Okay, as I see that in the very next question, you have such kind of function. Your fx is given with such type of thing. This is a trigonometric question. Okay, I'm just giving you a hint. You have to solve it. Okay, see, 1 minus cos 4x. We know 1 minus cos 2 theta is 2 sine square theta. I hope you are remembering this. So here 4x. So what they have done, they have doubled this angle, so they need to double this also. They mean to say 1 minus cos 4 theta can be written as 2 sine square 2 theta, because if you are doubling here, so you need to double this angle as well. Okay, so 1 minus cos 4x can be written as 2 sine square 2 theta upon 8x square. Now this 2 with this 8 can be easily cancelled. Sine square 2 theta upon 4x square. Now this whole can be written as sine 2x upon 2x the whole square. Can we write like this? Okay, sine 2x upon 2x the whole square. Now by the identity, or maybe somewhat here maybe h would come on solving, it's RHL or LHL. So it will become 1 square is 1. So finally, so I'm just giving you a hint for this question. Do it. Okay. Okay. Now this question number 22nd. Fx is given to us in such a way, and it is continuous at x is equal to 1. Continuous at x is equal to 1. We need to find the value of a and b in this. Now two unknown constants they have asked. Very easy to understand. I hope you will understand. I'll give you the hint. Rest you solve it. Okay. It is continuous at 1 means its three values can be equalized. Its value on the particular function which is given to us 11. So can we write limit x tends to 1 of fx, which is f1, we are given with 11 as the. So keep this aside because it will be very much helpful for solving. Can you just tell me among these two which will go for the LHS case and which will go for the RHS case? So it is very easy to find from these two. X is greater than 1 means for sure it is RHL and this is LHL. So for RHL, I'm writing here, I'm equalizing this with 11, okay, because at last we'll get the same only, okay. So or else you just solve, okay. So for RHL, limit x tends to 1 plus of fx, which is h tends to 0, 1 plus h. In place of x, just put 1 plus h plus b. Limit h tends. On putting the limits, we'll get 3a plus b. Similarly, in place of this, I'm directly writing for LHL. Please you understand. Finally, you will get answer as 5a minus 2b. Now, RHL can be equalized with this. So, 3a plus b is equal to 11. And this also with this. So, okay. Now, they two are linear equations. Solve it. You will get the value of a and b. I hope this is clear. Okay. Let's do one more question and then we'll wrap up. Okay. 23rd question now. Consider the following function defined as follows. For x not equal to 0. This is for x not equal to 0. In each of the case, what choice of f0 will make the function continuous at x is equal? You are given with two questions. This is the first question I am taking and the second one, okay. So you from among these two you have to check which function is continuous at x is equal to 0, okay. So we have to check its LHL and RHL both so that to make it proved, okay. But before that, I just want to recall one of the identity which is very, very important for us in 12th class and which we have already studied in 11th class. I hope you are remembering this identity. When limit x tends to 0, x to the power n minus a to the power n upon x minus a is na to the power n minus 1. I hope you are getting this identity, okay. This is the very important identity which we are going to use in this question. How? Let's start. I told you that to make this function continuous, its three values should be same. That means its value on the function, its LHL and RHL. So first of all, let's find the value when x is equal to 0 on this function. Means what we are trying to find, limit x tends to 0 of fx. Okay, so we are given with 1 minus x to the power, this is cube root, can I write this as power 1 by 3? Okay, minus 1 upon x. Now limit x tends to 0. Now we cannot put x tends to 0 here, because if I put x is equal to 0, so 1 minus 1 0 upon 0 by 0 form, which is an indeterminate form. So we don't have to go that way. We have to apply the identity in such a way. Okay. So how to mold this thing into the identity? What things we have to do here? See, this x should be same. Now here we have 1 minus x and here x only. So here we need 1 minus. But if we are doing 1 minus, so x will become of minus 1. So first I'm just adding 1 and subtracting 1 in the denominator. So let's do. And after that, how I am arranging, just see here. From this minus 1 and this plus of x, I am taking minus common. Okay, or else yeah, so it will become 1 minus of x, and above this can we write in yes, such a way. Okay, so finally it will be 1 minus 1 minus minus plus of x will get the same. Okay, now here you again make a arrangement and take minus common. So here it will be what? Minus 1 minus, okay, wait, the question is of positive. I wrote negative here, that's why we are getting some issues here. We cannot arrange in the proper way. Then I again thought maybe some mistake, so I went to the question. See, this can happen with you in exam also. Maybe if you are correct at your place, and if you are finding any difficulty or challenge, please go to the question and check whether you have written. So same happened with me also. Okay, it is plus over here. Now we have to arrange that in proper way. That means 1 plus x here and minus of 1. Now the things are totally correct. Okay, so can we write 1 as 1 to the power 1 upon 3? So this is the identity. So x, so both x here, and AA is also 1, n, so 1 by 3, 1 by 3. Now can we write this as NA to the power n minus 1? So finally n is what? 1 upon 3. A is what? 1 to the power n minus 1. So whatever to the power 1 is 1 only. So we got 1 by 3 as the answer. Now for RHL case and LHL case, I'll just explain you for the RHL. RHL directly h tends to 0. 1 plus 0 plus h to the power 1 upon 3 minus 1 upon 0 plus h. So we will get 1 plus h to the power 1 by 3 minus 1 upon h. The same case here, add 1, subtract 1, you will get 1 by 3 as the answer. Now for the subtraction case, see for the LHL case, it will be minus. So it will give you 1 minus h to the power 1 by 3 minus 1 upon minus of h. This is very helpful. Now you need to add 1 and subtract 1 to get the above result, and this answer will also be 1 by 3. And that is how you can prove 1 by 3, 1 by 3, 1 by 3. So hence it is continuous. For the next one, just go and find. Okay, so that's it for this exercise. I hope the things are clear to you. Okay, do the practice of example, that is very important. I repeat in each and every lecture. Now in the next lecture we will come up with the continuity of a function in an interval. How in an interval we can find that whether the function is continuous or not. Okay, so just let's wait for that. Thank you so much. Do practice. Bye bye. Thank you so much.